Crawling around on 8 legs are some of the most fascinating invertebrates on Earth. More than 34,000 species of spiders roam every continent except Antarctica. These creepy creatures can survive almost anywhere, even in water, as long as food lives nearby. Spiders are members of the arachnid class that includes scorpions, ticks, and daddy longlegs. They differ from insects in several ways. Spiders walk on 8 legs, while insects have 6. They also have 2 body parts rather than 3. And unlike most insects, they don't rely on antennae or wings as they move around. They have other advantages instead. Best known for spinning webs of silk, many spiders use these webs to ensnare their victims. Silk comes from special glands located at the tip of their abdomen. Delicate and deadly, a spider's web traps almost anything that comes in its path. Flying insects are particularly vulnerable. Tiny hairs on the legs of spiders give them an acute sense of touch. They feel the vibrations of a victim and move toward the catch. Sometimes they save food for later by wrapping it in silk and storing it away. So how do spiders avoid getting stuck? Special claws on their legs help them hook on to silk strands and move around. They also make different kinds of silk, and some of it isn't sticky. Spiders depend on silk for many purposes. Besides catching and wrapping food, it protects their eggs, helps them climb, and provides a bit of shelter. While all spiders make silk, not all of them spin webs. Those that don't rely on highly developed senses to survive. With its sharp vision, the wolf spider lives on the forest floor in search of a catch. This green-leg spider lurks in the flower blossoms, ready to ambush its prey. All spiders kill their prey by dispatching powerful poisons through their fangs. But very few spider bites are actually dangerous to humans. Perhaps one reason we fear spiders has something to do with their looks. Thanks to its hairy legs and big body, this tarantula has a bad reputation. But to most people, its bite is no more harmful than a bee sting. Spiders are amazing predators that have survived for around 300 million years. They play an important role in their ecosystems. Without them, insect populations would spread out of control, killing crops and spreading disease. They also make a fine meal for other creatures. So the next time you want to get rid of a spider, think again. They might make our skin crawl, but they're more useful than we realize.
It's fall in the Pacific Northwest of the United States, and the rivers are choked with salmon. Thousands of these fish are returning to lay eggs in the place they were born. Salmon get their start in these rivers. The cold, clean, and well-oxygenated water is vital to their initial survival. But soon after they're born, they leave this fresh water for a life in the sea. Unlike most freshwater fish, salmon move freely between the two environments. A salmon's brain sends hormones to its body so it can adjust to changes in salt content. The fish spend as many as 8 years swimming in the sea, then head back to fresh water to lay their eggs. most return to the exact stream where they were born. Scientists think they rely on the Earth's magnetic field to guide them in the ocean. Then their sharp sense of smell directs them to the right stream. It's a treacherous, often uphill journey, but these salmon are built to take it. They navigate around tricky obstacles, jump through waterfalls, and log hundreds of miles on their way. If that weren't enough, they also have to dodge dozens of predators in search of a good meal. Traveling against the river's current can be exhausting, but a calm pool behind the rocks provides a good place to rest. Near the end of the trip, salmon stop eating and their skin turns red. The pigment that colors their flesh moves into their skin as they use up stored fat. Finally, they reach a shallow location ideal for laying eggs. The females dig a nest in the gravel, while the males guard against predators. A female salmon can lay more than 3,000 eggs at a time. The males protect the eggs until the females die. This journey marks the end of a salmon's life. Worn out and starving, both males and females die soon after spawning. As their bodies decompose, they provide nutrients for the next generation. After about 4 months, the salmon eggs hatch. The young fish spend several months in the river before heading to the sea. This amazing cycle begins all over again. Elephants are the largest of all land mammals, but they walk softly, on tiptoe, with thickly padded shock absorbers surrounding bone. Nose and upper lip stretch out into a long trunk loaded with 150,000 muscles. This boneless limb acts as a hose, nose, and hand. The elephant's legs are adapted to support great weight on bones built like pillars. The evolution of this marvelous modern mammal began over 50 million years ago. Ancient ancestors looked more like pigs than elephants. Short legs, long body, and a stubby, flexible nose served these animals well enough in the marshy regions they called home. Over the next 10 to 20 million years, generation after generation of elephant ancestors increased in size, naturally selected for success in a changing environment. As they grew taller, the animal's lower jaw elongated beyond the upper and allowed them to continue to feed on the ground. Their snouts began to take the shape of a trunk and covered the lower jaw. Elephant heads weighted with heavier trunks needed the support of shorter, stiffer necks. But long lower jaws proved more cumbersome than a multitasking tubular limb. Trunks were naturally selected over droopy jaws and allowed the tall animals to feed, drink, bathe, and lift heavy objects. Nostrils shifted to the tip of the trunk. Now elephants had built-in snorkels and could breathe while submerged in water. Approaching predators could be sniffed out. Today, 2 species of elephants roam territories in Asia and Africa.
The easiest way to tell the difference between them is to look at their ears. Asian elephants have smaller ears than African elephants. Natural selection makes each the right size. Elephant ears are actually giant cooling systems. As the elephants heat up, they are able to open more and more blood vessels in their ears. All 100 gallons of an elephant's blood can be run through the ears in 20 minutes. Flapping their ears cools the blood before it returns to the body. African elephants, exposed to longer periods of sun, need bigger cooling systems than Asian elephants. Random changes in the genetic makeup of each species allowed them to evolve for their specific environments.